Hey guys, sorry I'm gone. I'm over across the district office. As you know, I just told you and left the room. Kind of creepy that I'm not talking to you on this, but that's okay. What we want to do is we want to divide polynomial functions today. We've been graphing different things. This is going to help us be able to do a lot more with these polynomials as we continue forward, but we have to be able to do long division, synthetic division, which you'll like, and remainder and factor theorem. I want to go ahead and jump straight into the division of polynomials using long division, but before we can do that, we have to remember how to divide just like when we were in elementary school. So if I wanted to do 122 divided by 4, process is not changing, always the same. How many times does 4 go into 1? Well, that's none. How many times does 4 go into 12? That would be 3. 3 times 4 is 12. Put it underneath. Always subtracting here. 0 and 2. Well, how many times does 4 go into 2? That's none. But how many are left over? Well, that's your remainder of 2. This remainder thing is going to be extremely important later. We'll get there, not this problem, but the next problem we're going to probably see one. Possibly. We'll just see what happens, and when we get to that, I'll kind of show you how to work with those. But I want to go ahead and I want to show you how to do long division with polynomials. It is no different than the problem we just did and that I just erased. So, setting it up, just like you have a million times, but here's the key. If you notice in the problem, it's skipping an x squared. You don't get to just skip them. You have to put them in there, and I'm going to put a kind of a placeholder in there. So 0x squared. Then I can continue minus 13x minus 12. Now I can actually do the division piece, and here's where you have to kind of pay attention. The process is still the same, just it looks a little bit different. The thing you're worried about is this first term. What do you have to multiply x by to get x cubed? Well, that would be an x squared. So x squared times x is x cubed, and you can't forget to multiply the x squared to the negative 4 as well, so negative 4 x squared. In long division, you're always subtracting at this point. X cubes eliminate. 0 minus negative 4x, or 0x squared minus negative 4x squared is a positive 4x squared. And then just bring everything else down. You don't have to, that's just kind of how I do it. Well, now the process is repetitive. What times x gives you 4x squared? Well, that'd be a 4x. Then 4x times x. 4x squared. 4x times negative 4. Well, sorry, I forgot an x up here. Negative 16x. And it's always subtracting. Sorry about this stuff off to the side. My hand keeps touching it. I don't know what's happening here. But subtract. 4x squareds eliminate. You get a 3x minus 12. Now we can almost finish the problem. What times x gives you 3x? Well, that's a 3. 3 times x is 3x. 3 times negative 4 is negative 12. Subtract and you get 0. So your remainder is 0. But you don't get to keep your answer like this. You got to go off to the side somewhere and say that, well, my answer is x squared plus 4x plus 3. It's not a crazy process. It's very repetitive. You kind of have to stay with it and keep an idea of where everything is placed. You have to be organized with this stuff. Same process every time over and over. What is x? What do you multiply x by to get x cubed? Put it up top. Multiply to all the terms over here. Subtract. Then continue the same process over and over. Looking maybe at a slightly more difficult problem, just bigger numbers here. So we're going to have to look at this and set it up the exact same way. If you notice, we're missing an x squared on this one as well. So I'm going to get it set up 3x to the 4th minus 2x cubed. Plus, I need that placeholder in there, 0x squared plus 7x minus 4. So, process starts the same. What times x gives you 3x to the 4th? Well, we know that's a 3x to the 3rd. Multiply everything out. 3x to the 4th. That would be plus 9x cubed. Subtract. Those are gone. Here we have a negative 11x cubed plus 0x squared plus 7x minus 4. Continue further here. What times x is negative 11x cubed? Well, negative 11x squared. You can see the numbers are going to start to get big here. If I have a negative 11x squared, I have to multiply it, negative 11x cubed. negative 33 x squared. Do my subtraction. Those eliminate. 33x squared plus 7x minus 4. Keep going here. What times x is 33x squared? So 33x. So this is a 33x squared plus 99x, and I do my subtraction. Well, if I do my subtraction here, negative 92x minus 4. Excuse me. So multiply it out again. So negative 92 and negative 92 times 3. It's really not hard. 9 times 3 gets you 27, or 90 times 3 is 270, plus another 6. That's a 276. So negative. And do your subtraction. Those are going to eliminate. I believe you have a remainder of 272. Here's the key, though, with this remainder. You can go ahead and write down your answer. That's fine. But you can't forget the remainder on there. So 3x cubed minus 11x squared plus 33x minus 92. And here's the key. I don't care if it's a positive or negative remainder. You're always going to put addition there. We had 272 as our remainder, but you have to put that over whatever you divided by. This right here would be your answer. Whatever your remainder is, it's plus, and it's over whatever you divided by. In this case, it was the x plus 3. Nothing too crazy. A little bit harder. It is a tedious process, but it's very repetitive. If you know how to do the first step, you know how to do all of them. So just focus on that for me when you're looking at these problems and doing them. They're really nothing too crazy. Give you a second to kind of catch up here. All right. We have to figure out if things are actually factors of one another. The biggest thing we have to look at is the last two problems. On the first problem we did, we had a remainder of 0. The other one, we had a remainder that was some number. The key is, if there's a remainder of 0, it's a factor. That's the big thing. If you do the division and you end up with a remainder of 0, that, whatever your answer is, that is proving to you that you have a factor. So I believe in the first problem, if I go back real quick, this x minus 4 was what we started with. That means x minus 4 is a factor of x cubed minus 3x minus 12. So you could factor this thing all the way, and I promise you x minus 4 will pop up. And the second one we did didn't necessarily turn out to be a factor, so if you factored it all the way, that would probably not be one of your factors. Pretty easy concept to grasp there. This one's slightly more difficult. Process is still the same, and I want you to try it yourself and see how it goes. I'm going to work it out, but if Mr. Garth will go ahead and pause it real quick so that we can kind of let you guys try and work this one out. I'm going to go ahead and work it out, and we'll put it up on the screen here in about 2 or 3 minutes. If you did the problem right, it actually turns out to be pretty easy. You only have to do really 2 steps here, and you should see that x plus 4 should be your answer. A remainder of 0, which means that x squared minus 4x plus 3 is actually a factor of x cubed minus 13x plus 12. Kind of interesting. Looks scary. Not too bad. The process is still the same. If you need Mr. Garth to pause it so you can kind of look at my work to kind of get an idea of what I did, go ahead and ask him to do that. Otherwise, we're going to go ahead and move on to something I think you're going to like a little bit more, and that is synthetic division. This is a certain process that you need to follow. It's so much nicer than long division, but there are going to be times where I say that you have to use long division over synthetic, and there are times that you really don't have a choice. It's not up to me, it's not up to anybody else. You just have to use long division. If you can use synthetic, you can. The only times you can use synthetic, though, and this is key, you can only use it when you are dividing by a linear binomial. In other words, x plus or minus some number. Okay, doesn't matter what that number is, but if it's x plus a number or x minus a number and it wants you to divide, you can go ahead and do that synthetic division. So if we take a second, we're going to go back and we're going to actually do synthetic division with the first 2 problems. Okay, the First one that we did earlier today was actually the x minus 4, and then what we wanted to divide it into was a 0x squared minus 13x minus 12. Nothing too crazy here, but this process can be tedious and long, so I want to go ahead and show you the better way. If you have a problem like this, it is a linear binomial, that is key. What you do is you take whatever the number is, and actually put that in a little box up here. Technically, you're solving for x, so you could do x minus 4 equals 0, solve for x. Whatever that number is when you solve for x is, that is what you put in the little box here. After that, all you do is you put the coefficients of each term in here. Again, you cannot forget the x squared. It didn't have an x squared in the original. You can't forget it now. So it's a 1, a 0, negative 13, negative 12. And now the process is very, very easy. The first thing you do is bring down that first term. So bring down the 1. Well, at this point, it's multiplication. 4 times 1 is 4. And in here, I'm always adding. So 0 and 4 is 4. 4 times 4 is, we have a 16, always adding. So a 3, 4 times 3 is 12, and you get 0 here. This number is always, the last number is always going to be your remainder. So that's kind of key. If you notice back on the problem when we did it, our answer should have been something like, I think it was x squared plus 4x plus 3. Here's your coefficients. The nice thing is we started with an x cubed. Way up here it was x cubed. Well, whenever you do the division on synthetic, it always goes down, the exponent always goes down by 1. In other words, this thing means I have an x squared plus 4x plus 3. That's your answer. That's what it should have been, I believe, in the first problem. That's what it is now. I think this process is a little bit better. You have to keep in mind you bring down the first term. Just bring it down. Multiply by what's in the box. Put it here, and you're adding this term. You get 4. 4 times 4 is 16. Put it up here. Add them. You get 3. 3 times 4 is 12. Add those, and this is your remainder. Of course, if you had the remainder, you would go ahead and put plus whatever it was over x minus 4, but in this case, we don't have one. I want to go ahead and look at the second synthetic problem as well. If you go ahead and look at this one, what we originally had was we had x plus 3. So if I have x plus 3 is what we're dividing by, that means I'm going to have a negative 3 in the box. And then I was dividing by, I believe it was 3x to the 4th minus 2x cubed plus 7x minus a 4. Well, leading coefficient goes here, followed by the negative 2. It skipped x cubed or x squared, so you got to have a 0, 7, and a negative 4. Bring down your first term. That's a 3. 3 times negative 3. That would give you a negative 9. Now you keep going. You add those. That's a negative 11. Multiply negative 33, which gives you a negative 33 here. Keep going. You get 99. Well, if you add those two together, you're going to get your 106. Multiply, and I'm going to pause this actually real quick. Sorry about that. Someone popped in my door here, but actually, as I was talking to them, I realized I made a mistake in this problem, and that's okay. We can go back and erase the 106, the 99, the negative 33, and the negative 33 here. Where I messed up is negative 3 times negative 11 is that positive 33. So then you add your 33. This gives you a negative 99. Now we have, because we add at this point, that's a negative 92. And if we have that negative 92 again, 3 times 90, you get 270 plus another 6. So positive 276. We add those together, 272. This piece is our remainder. Again, we started with an x to the 4th term. That means we have an x to the 3rd term in our answer. So 3x to the 3rd minus 11 x squared plus 33x minus 92 plus our remainder, 272 over whatever we divided by, x plus 3. Synthetic division is so much easier than long division, but I would just kind of wanted to give you an example of that. So go ahead and go to that homework. We'll pick up the other stuff when we get back to it on Friday. Have a good day.